Hello and welcome to Mr. Pi the Maths Guy. In the last episode we looked at the different kinds of number systems that had been developed by various civilizations over the previous thousands of years. And we noted how the Babylonians had a system where they created just two symbols and used multiple versions of those symbols to count numbers. The Egyptians used a series of different images, each to represent a different 10 times value. So we had a symbol for ones, tens, 100s, thousands and 10,000s and so on. And we saw how the Romans used letters to represent different values: 1, 5, 10, 50, 100 and so on. We ended by looking at our own system, which is based on the Hindu Arabic system and has 9 value symbols, 1 to 9, and subsequently it was added a 0 as a placeholder for when there was no value in a particular column. Well, today I'd like to look at that system in more detail. So let's take a look at a particular number. Here we can see the number 34,652. And we can see that the value of these different digits here, these 5 digits, is a mixture of both their digit value and their place within the overall number. So let's see how this actually works in terms of their place value. We can see that the 3 is placed into the column of 10,000s, the 4 in the thousands column, the 6 in the hundreds column, the tens has a 5 in it, and the 2 goes in the units or ones column. Now each of these digits is then represents a particular value. For example, we have 3 lots of 10,000, 4 lots of 1,000, 6 lots of 100, 5 lots of 10 and 2 lots of 1. So altogether we have 34,652. And each of these numbers is represented by both their place value and their position value. Okay, now this place value or positional value is really important to our number system, and actually a really good understanding of this positional value can really help children and adults understand calculations much easier and make the process of the various calculations they'll be making, whether they be addition, subtraction, multiplication or division, much easier if they begin to think of positional value. So let's have a look at this in practice. Here we have the number 26, and you can see that the number 26 is generated by 6 lots of 1 in the units or ones column and 2 lots of 10 in the tens column. Now if we are to add another number to this, say we are going to add the number 15, we can place the ones into the ones column, so placing them in, but when we've placed 3 of them in, we have no space for any more ones to go in, so we need to think about moving something into the tens column. So we do this by placing an extra 10 into the tens column and clearing out the ones column completely. We can now place the final 1 or unit into the ones column, and we can now place the remaining 1 into the ones column, giving us just 1 in that column, so we change the digit to 1, and then the final 10 we can place that into the tens column, and now we have 4 tens in that column, so we change the digit to a 4. So we now have the number 41, 1 in the units column and 4 in the tens. 4 lots of 10 and 1 lot of 1. This method of using the value of its place is really important to our method of maths calculations, and actually speeds up the process because we have to think of much smaller numbers when we are making calculations, as we only need to calculate for the unitary value of the digit and not actually take too much consideration of its place value. After all, its place will be determined by where it was in the original number. So let's have a look at this again with a 3-digit number this time. Here we have a 3-digit number. We have 2 in the hundreds column, representing the 2 hundreds in that column. We have an 8 in the tens column, representing 8 lots of 10, and a 4 in the ones or units column, representing 4 ones in that column. Now if we were to add another number, here we can add 123, we can see that we can easily add the units in, as these will not take us over the maximum value that we can have in that column. But when we come to add the tens in, whilst we can add one of the tens in, we can't add this second, because this will take us over the maximum for that column. So we need to then move into the next column and add an extra 100 into that column. We can then clear out the tens column, as these are no longer required because we have now substituted their value and the extra 10 to make 100 into the hundreds column, and then the remaining 100 is placed in the hundreds column. We can now see that we've put all these numbers into place, and we can see that in the hundreds column we now have 4 lots of 100, so we change the digit to a 4. We look in the tens column and there are no value of any tens in there, so this is where we use the notion of 0 as a placeholder to hold that value column of tens as being empty. We then look at the ones column and we have 1, 2, 3, 4, 5, 6, 7, so we change the digit to 7, and we have our final number now, 407. 407 units. There is nothing in the tens column, and this is represented by a 0 holding the place of the tens column as being an empty column. So this shows you how significant the place value system is. By using this place value system, we are able to make calculations in relatively small numbers, because we don't need to worry about whether we're talking about 400, 4000, 40 or 4 ones. It's just 4. Its actual total value is recorded by its position within the number as well. So when we're adding two numbers together, 2 and 4 will add up to 6, whether that be 2 and 4 in the ones column, or 2 and 4 in the tens column, or even in the thousands or 10,000 column. It doesn't matter that the total value of those digits, only their individual digit value is necessary to make the calculation. Now the invention of the 0 is actually a really crucial part of our system. Because if we have a look at a new number, again putting the numbers into the columns, we can see here we have 3 in the 10,000s column, 5 in the thousands column, we have nothing in the hundreds column, 8 in the tens column, and 4 in the ones or units column. Now if we were to record every number in this manner with actual columns headed up, then there would be no need for us to put anything in place for the hundreds. We can see that that column is empty. However, by the invention of the 0, we can do away with this notation of having to say what column each number is in. And simply by using the figure 0, we can place that so that the 0 tells us that this column here of 100s is empty, and it separates the thousands value from the tens value. By the way, this comma is often added just to split the number up into various blocks of 3 digits, simply to make reading the number easier. the number is no different whether that comma is there or not. It simply is added, in most cases, just to make reading the number quicker and simpler. So we can see that this invention of zero allows us to have a place value. It allows us to record a number quite simply by having a place value of 0. It enables us to show all of the different columns without actually having to write up headed columns. And that simply is all the 0 is for, is to tell us there is a column with nothing in it. So when we look again at the number 1 million, we can see that whilst there is 1 in the million column, all the next 6 columns, the 100,000s, the tens of thousands, the thousands, the hundreds, the tens and the units, all have a 0 value, and therefore that helps us recognise that the only digit of value, the 1, is in the 7th column, which represents the millions. I hope this has made sense, and I hope it helps you understand the importance of place value and how understanding this place value system is crucial to children working through calculations, not because they can't do it without recognising the place value, but if they do recognise the place value and can work with it, it makes their calculations so much simpler. Thank you for watching. Next time we'll have another topic to look at. In the meantime, go figure. Bye.